P12 areas of similar triangles. This is going to be the last lesson for Unit P. Then you're going to have a test. So get ready for it. Now, whenever we're talking about areas, let's talk about what this is right here. These are lengths, 8 meters and then 3 meters. But if we used a formula to be able to find the area, if I was a stickler and I told you to put the units at the end, area is always units squared because we multiply a meter times a meter, so we get a meter squared. So whenever we're talking about areas of similar triangles, it's going to be done just a little bit differently. So what we're going to do is find the length ratio, and after this I'm just going to put LR for length ratio. The length ratio is 8 to 3 from left to right. Okay, so if the length ratio is 8 to 3, to find the area ratio, and after this I'm just going to put AR, we square both lengths. So 64 over 9. So if this is 60, the area is 64 meters squared here, then the area on this similar triangle is going to be 9 square meters, because it was already, this was 64 and this is 64, so that was already 9. I'm going to change a little bit later on though. Okay, so the length ratio is 7 to 2 because they give us both of those. So the area ratio, we square both of them, and it's 49 and 4. Since this is 49, then this is 4. The length ratio is 2 to 6. You want to reduce that. 2 to 6 is 1 to 3. So the area ratio is this squared. 1 times 1 is 1, 3 times 3 is 9. Okay, but these areas is not 9, 36 is not 9. So let me see if I can explain it a little bit better. The areas ratio reduced is 1 to 9. But if the second ratio, if the second square is 36, and that's the area, and we want to know the area of the first rectangle or square, then we would set this up. This is the given ratio, what that is right there. Then we cross multiply and divide. 9 times x is 9x, 1 times 36 is 36, divided by 9, divided by 9, x is 4. So the area of the rectangle, the green rectangle, is 4. The length ratio is 1 to 4. So the areas ratio of that given information, if I square both of those, 1 times 1 is 1, 4 times 4 is 16. Then I take this and set it up as a proportion and cross multiply. So 16 times x is 16x, 1 times 80 is 80, divided by 16, 5. So the area of this rectangle is 5. The length ratio is 8 to 6, but I'm going to reduce that to 4 to 3. The area ratio of 4 to 3 is 16 over 9. Then we use, we use what we know and what we don't know. I'm using a calculator. 45. So if the area of this triangle is 80, the area of this triangle is 45. If the ratio of the square's area is 16 to 9, so they are giving me the area's ratio, which is 16 to 9. All this other time, they've given us the length ratio. We've squared it to be able to get the area ratio. So if they give us the area ratio, we're going to square root it to get the length ratio. So that would be 4 to 3. Then we're going to use this information and do 8 to v. Cross multiply. Divide by 4 and you get 6. So v is 6. What is the ratio of the area of the smaller hexagon? So you do 4 to 6. We're going to reduce that. And these are your length ratios. So to get the area ratio, we're going to square both of those and get 4 to 9. It says put it with colons between them, so we're going to put it with colons between them. Same thing. What is the ratio of the area? So the length ratio is 7 to 5, but that does not reduce. So if we square both of those, we get the area ratio 49 to 25. And we're back to the other stuff. So the length ratio is 1 to 4. The area ratio would be this squared, which would be 1 to 16. And since that's 1, then this is going to be 16. Okay, what is the ratio of the diameter of the smaller circle to the diameter of the larger circle? The length ratio the area ratio that they give us is 18 to 98. I am going to reduce that by 2 and get 9 to 49. So if this is the area, it has been squared. So to get the length ratio, I'm going to square root them. Because diameter is length. Diameter is how long it is between the center of the circle to both edges.